Good afternoon. I am Professor Dr. D.N. Zamre, Head Department of Chemistry, Kisan Veer Mahavidyalaya, Y. Last lecture, we have discussed about non-aqueous solvent liquid SO2. Then, today we are going to discuss about non-aqueous solvent liquid SO2. Before proceeding that, first of all, we are going to last lecture leveling effect of the liquid NH3. It means if you observe that these are the some of the leveling effect and amphoteric behavior of liquid ammonia. On the basis of that, we are going to say number of reactions which are highly impossible to carry out in the water media, because universally you are going to accept that water is a universal solvent, because number of reactions in the research methodology, in the laboratory, even domestic purposes, we are going to utilize water. But some of the reaction it is highly impossible to carry out in the water. That reaction can be, we are going to carry out in the non-aqueous media like liquid SO2 and liquid NH3. In case of that leveling effect, we are going to discuss that when any acid which is a weak acid in the water, that becomes strong acid in liquid ammonia. And if you observe that urea is a neutral molecule in the water, but it becomes a acidic media in the liquid ammonia. It means some behavior of solvent goes on changing in that particular liquid ammonia as a non-aqueous solvent, because due to the property of minus boiling point, freezing point, specific conductance, on the such a way we are going to discuss this number of reactions which is carried out in the liquid SO2. For example, if you see the physical parameter, if you observe that suppose if you take like ammonia, we are going to discuss this liquid SO2. Liquid SO2 we are also going to discuss in different ways, like physical properties. First, what are the physical properties? Physical property, it is nothing but liquid sulfur dioxide is a non-aqueous, inorganic, aprotic acid type of polar and ionizing solvent. What is meaning of that? Aprotic, it is nothing but proton is totally absent, and polar, it is nothing but we are going to form positive and negative terminal or positive or negative poles. For example, sulfur dioxide when undergo atoionization reaction, it is giving rise to such a type of, suppose if you take SO2 combined with SO2, it is giving rise to SO3, SO plus thionyl ion plus SO3. It means here, suppose if you take, this is the SO plus and SO3, this is called as thionyl ion, this is called as a sulfite ion. It means undergo atoionization. There is a formation of positive and negative parameter. That's why it is a polar in nature. It means if you observe that degree of ionization is much less than that of water, because water is called as a universal solvent. That's why number of reactions we are going to carry out in the water, but there is a limitation to carry out the reaction in the sulfur dioxide. What is the reason? Because its physical properties, like boiling point is the minus 10 degrees centigrade, freezing point is the minus 75 degrees centigrade, dielectric constant it is a 17.3, and specific conductance is the 3 multiply 10 raised to minus 8 ohm raised to minus 1 cm raised to minus 1. These properties are most important one, because number of reactions which are highly impossible to carry out in the water, that can be carried out in the liquid SO2 or liquid NH3 because of only this property. It means here, then we are going to discuss, this is the inorganic polar atoionizing solvent. And what are the solvent action? Solvent action, it is nothing but which type of salts get dissolved, which type of organic compound get dissolved in liquid SO2. For example, if you observe solvent action, sulfur dioxide dissolve alkali metal halides where solubility decreases from iodine to fluoride, I to fluoride, I minus to F minus. It means halogen salts which are get dissolved in sulfur dioxide, dissolve in alkali metal halide. Alkali metal halide, it is nothing but the elements which are present from the first A group. For example, NaCl, KCl, MgCl or NaF, NaI, whatever it may be. When halide get react with the alkali metal, that salt which is get formed, it is a solubility decreases from halide, decreases from iodine to fluoride, I minus to fluoride, because electron negativity goes on, increases from fluorine to iodine, but the solubility goes on, decreases from iodide salt to the fluoride salt. Then next one is the ionic halides. Divalent metal shows the lower solubility iodide to soluble. For example, bivalent, it is nothing but the metal which are present in the second A group metal. For example, beryllium, calcium, magnesium, strontium, when react with the halogen and the salt which is get formed, that solubility goes on, decreases. Then next one is the metal oxide. Suppose metal oxides like sulfides, sulfates, hydroxides, etc. are practically insoluble in liquid SO2. That is not soluble. Then next one is the alkali metal sulfide. Alkali metal sulfide, it is nothing but K2SO4, then Na2SO4. First A group metal when react with the SO4 group and then sulfide formation takes place. All these are practically insoluble in sulfur dioxide. Then next one is the alkali metal. Alkali metal sulfide, acetate, thiocyanate, cyanides are much soluble. This is the solvent action. Many of the ammonium, mercury and thallium salts, etc. due to the covalence are soluble in the liquid SO2. It means majority of the sulfate, chloride, halides are soluble in the SO2. Then next one, suppose if you take many of the covalent halide like BeCl3, AlCl3, AsCl3, organic amine, then ethers, alcohols, etc. are soluble, freely soluble in the liquid SO2. Then last one is the similar to the liquid ammonia, liquid sulfur dioxide and all types of the reactions having studied, let us concentrate on the acid and reaction only. It means we are going to next proceed for acid-base reaction. For that purpose, if you see what are the acid-base reactions present in the liquid sulfur dioxide. See now here, this is called as acid 1. This is called as acid 1. This is called as acid 2. When acid 1 combine with acid 2, then it means this is also called as atoionization reaction. SO2 combine with SO2, it is giving rise to SO2 plus and SO. That this is called as sulfite ion. Actually SO4, SO minus. Thionyl ion and sulfite ion formation takes place here, and this is the SO3 minus. This is called as atoionization reaction. In this particular reaction, sulfite against the thionyl chloride can be followed by conductometrically, and typically neutralization curve is obtained. This is one type of neutralization reaction. Then this is the neutralization reaction. When SO2 combine with K2SO4, this is acid, this is the base. This is giving rise to salt and solvent. In neutralization reaction, if you observe, the acid combined with base, it is giving rise to salt and water. But in case of liquid ammonia, when this acid combined with base, it is giving rise to salt and water. And last article is the amphoteric behavior in nature. In amphoteric nature, what happened that zinc 2 in different two reaction when combined with K2SO3, it is giving rise to ZnSO3 and K2 ZnSO3 twice as adduct. It means here same metal in one reaction is acting as acid and same metal in the another reaction is acting as base. Similar way, aluminum plus 3, this is the Zn second, and then aluminum third is also acting as similar way. Here aluminum in one reaction is acting as acid, in aluminum in second reaction is acting as base, and likewise same metal in different two reaction acting as acid as well as base, that is called as a amphoteric nature. And last one is the this is the end of topic. Thank you.